Hello, and welcome to another Reigate Maths video. My name's Simon, and in this video we're going to be looking at the Algorithms on Graphs chapter of the first year of the Decision 1 unit for the Further Maths specification for Edexcel. This video is the second of two videos on Prim's algorithm. This one is focusing specifically when we are given Prim's algorithm in distance matrix form. If you haven't yet watched our first video on Prim's algorithm generally, I'd advise you do that, and I've put the link in the description below. Prim's algorithm on a matrix does the same thing as Prim's algorithm, because they are the same algorithm. It just does it in a slightly different way with different notation. With Prim's algorithm on a matrix, we actively annotate the matrix that we are given. We're still adding vertices to a spanning tree, but the big thing from an exam point of view for Prims on a matrix is that you are doing it actively on the matrix you are given. So here's the description of the algorithm. We're going to go through it very briefly and then have a look at an example. So we're going to choose any vertex to start the tree, similar to the way questions are worded in Prim's algorithm questions. And again, this is often given to you. We delete, so we cross out the row for that vertex. We then number the column in the matrix for the chosen vertex. We look in that column and we circle the lowest element, so the smallest numbered element that hasn't been deleted. If there's an equal choice, we choose either, and it doesn't matter. We then label that column and delete that row. We repeat this step until all rows have been deleted. Now, the description is a little bit clunky, so better to look at an example and show you how to do it. So here's our example. We've been given a very simple distance matrix there, and we're going to use Prim's algorithm starting from A to find the minimum spanning tree from the network. So we can see we're told where we're starting from, and this is a really important thing as well. List the arcs in the order that you select them. I would advise doing that even if you are not told to. It's just quite useful to have. As we've seen with both Prim's and Kruskal's algorithms, we've got a part of drawing the minimum spanning tree. So we're going to do that as we go, but not having the network in a picture form to start with doesn't give us a huge kind of grid to work with. So we're just going to draw it as we go. Okay, so I'm going to put A there. We can see we've got 5 vertices, so we're going to have 4 arcs in our minimum spanning tree. It's not a particularly big tree. So we're going to draw it as we go. Now we're told to start from A. So we delete the row for that chosen vertex. So we delete row A, we cross it out. I'm going to put A here, because that's our starting vertex. And then we number A row 1. Now it's up to you how you number them. You might want to put a circle around it. You might want to just number it like I've done there. You may want to number it with Roman numerals. It doesn't matter. But it has to be numbered, and the examiner has to know what order you're choosing things. Don't number it using letters. So now we look down this column and we pick the smallest undeleted number. So we've got 3 options to choose from: 5, 6, and 4. 4 is the smallest one. So we're adding E next to our minimum spanning tree because the 4 is in row E. We delete the row and we number the column because we have chosen E second. Now we chose the arc AE, so I'm going to list as we go. We now look down both columns and we pick the smallest undeleted number in either. And we can see that's the 3 here. So we've now added B. And the arc we've picked is BE. So we delete row B and number it 3. We now look in all 3 columns. We can see that the smallest undeleted number in any of these 3 is in D. So we've got AD is next. So AD's there. We delete D. And we number D with a 4. We now look in all the numbered columns and we pick the smallest number, which is 8. So we've added the arc CE. We delete row C. We number column C. We've deleted all the rows. So we're done. We can see that we've got our arcs in the order that we selected them. We've drawn our minimum spanning tree, and now all we have to do is work out the weight, and we do that by adding up the numbers that we've circled, which gives us 21. And that's prims on a matrix. Now you do have to be really careful. There is a topic in the second year called root inspection that has a very similar algorithm to prims. They are very, very similar in the way you do them and in the notation, but the way you apply them is slightly different. The key thing to remember is prims, you are looking at all vertices that have been added to the minimum spanning tree. That other algorithm, you just look at the last one. So be very, very careful that you know the difference. Sometimes with prims, you will be just adding to the last one you picked, but not guaranteed. So be careful there. But that's how prims on a matrix works. We've done this with a 5 vertex network, but in the exam, you might have to do it for maybe an 8 or 10 vertex network. But you just keep going until you've crossed out all the rows. Thank you for watching.